Stanford University.
All right, good afternoon, everybody. Welcome back to CS 193P Lecture 2. I kind of met briefly on Tuesday. I'm Josh, in case anybody's forgotten. I don't think you're going to see too much of Al today, but he'll be back next week. So, well, you can see the back of his head. He's kind of hiding up here. All right, so just a few announcements to start things off today. Enrollment is almost done. Hopefully everybody got through that on the website and got things in by Wednesday. We're going to shoot for getting end of day Friday, tomorrow. We're going to try and get emails out to everyone to let you know who's in, who's not. Obviously, there's a lot of people here, and we're taking 60. So, apologize to anyone who couldn't make it, but we're doing our best to accommodate everything and get things worked out. And we'll let you know hopefully by tomorrow evening. If you get notified that you're not in the class and have already signed up in Access, please do go back into Access and drop the class. We really need that for tracking purposes and all that good stuff. All right, so we've got some office hours set up. I don't actually know. Is Paul here?
I'm here.
Oh, hiding over there. Have you gotten stuff set up? I didn't know what they were. Monday, probably. Okay, so Paul's by next Monday. David, Mondays 4 to 6 at Gates 360. Paul, just yell real loud, and hopefully you'll find him, or he'll let you know on Tuesday. Man, this thing is pretty good. All right, so. If you haven't gotten started on the assignments yet, you need to get the iPhone SDK in order to get that working. For those of you that do end up enrolled in the class, as Al mentioned, you'll be invited to join the developer program. You'll basically, once you get the invitation for this, you're going to end up logging into the developer portal and requesting a certificate and doing some things. There'll be more information about that once we send out the emails about who's enrolled. In the meantime, we'll also need some UDIDs from that. In the meantime, for everyone who's here, and auditors will have to do this in the end as well, you can sign up for the free developer program, which is available on apple.com, developer.apple.com. And it's actually free for simulator development, so you'll be able to download the SDK and build apps and install and run them in the simulator. You just won't be able to install on the device. For auditors, if you do want to install on a device, it's only $99 for the on-device development, and you can sign up for that at developer.apple.com as well. But for everyone else who's going to be in the class, we'll be taking care of that. You won't have to pay the $99. But yeah, so developer.apple.com, download the SDK.
Sure. That $99, is that permanent? Or?
It's for the year membership. Sorry, the $99 is not permanent. It's a year-long membership. All right, so the first assignment kind of walks you through a bit of getting help and getting started. As Al mentioned, we don't actually have a textbook for this class. We're going to deal off of the Apple developer documentation. It's pretty rich. It includes a lot of information. So just a quick, brief overview of where you can get to some of that, what some of it is. If you go to the Xcode help menu, it actually has a whole bunch of it right there for you. The first thing in the menu is the developer documentation. You click on that, and you get a whole browser full of all the documentation that's a lot of the documentation that's available offline on your computer. It includes a bunch of the sort of broad overview documentation on large topics, as well as individual API documentation for specific APIs that you're going to be using. And that's all available right within Xcode. There's also the quick help in Xcode, which is kind of a shorter browser that just pops up a small window, and as you click on things in your text files while you're editing, it shows you an overview about what those things are. Both of those things are really great tools available right in the interface of Xcode while you're working on your code. It's a great way to learn about things while you're actually working on it. There's also the class header files. They're a really good source of information. The docs are great. We have a really great docs team at Apple, but we also have the engineers often write comments in the headers, sort of a one-on-one, us to you. They're a little bit less polished and, technically accurate. No, they're technically accurate, but if you get to the headers, you can get some good information in there. There's actually a shortcut to get to that. If you have something you're working on in Xcode in a text editor, and you've got an API that you just want to get a little more information about, if you hold down the Command key and double-click on that API, it'll open up the header and take you right to the spot in the header for that particular API. And hopefully there'll be some comment from one of us in there. And you can also go and check it out in the documentation where there's a lot more information. And also at the developer.apple.com, there's a lot of extra information. There's some great sample code and tech notes. Tech notes are kind of just additional information about APIs and topics that didn't quite make it into the original documentation, but that we think are interesting, stuff that's probably useful to know. So all that's available online on the sample code, and you can search it with Google search. It's all right up there. So we're going to cover a few things today. I just want to start out, see if anyone has any questions left over from Tuesday, stuff about the assignments, if anyone's gotten started. Anything, anyone? Yeah, what's up?
I noticed that on the handout it said thread release, and then in the, I guess in the 3.1 SDK it says like pool drain, so I'm assuming both just kill all the threads, right?
Oh, you mean pool release and pool drain?
Pool release and pool
yeah.
drain.
So the question is the assignment talks about pool release, and the documentation in the 3.0 SDK talks about pool drain for NS Auto Release Pool. The old model, they're actually equivalent. They do the same thing. In the past, you used NS Auto Release Pool. You would allocate one and then release it at the end, the same as other objects. In 3.0 and later, the recommended way now is pool drain, but they're actually equivalent. Yeah?
You mentioned on Tuesday that there would be an extra weekly session on Friday afternoon. Has that been decided for this week or not?
So the question is, what about the weekly sessions on Friday? We don't yet know the room that they're going to be in, I believe, correct?
Yeah, so my understanding is that we're still working out the room because we need to have the iTunes U guys there. But this particular Friday, we're planning on just having an extra office hours, dates 360, I think we said 3:30 to 5. Yeah, we'll send an email out for anyone who needs help getting their SDK set up.
Okay, so email out for anyone who needs to get their SDK set up. Extra office hours this week. Anything else? Okay. Oh, yep.
Well, I think I asked this during the first class. Anything that we develop here, do we get to keep the IP for it?
Yeah, anything you develop, you guys own. So.
I guess Apple Store and then like upload our app and we own every single part of it, or we don't have to.
Yeah. So the question is, anything that you make here, if you upload it to the App Store, do you own it? And the answer is yes. Develop your app and upload it to the App Store. It's yours. You know, just remember us. It's cool. All right. Okay, so we're going to get into some of the more basic language issues that you're going to be dealing with for the next 3 months here. We've got a slightly new set of extensions to C that you're going to be working with that are, compose the Objective-C language. So we'll talk about Objective-C, the language. We'll talk about object-oriented programming real quick, just a brief overview. Hopefully everybody's dealt with object-oriented programming before in other classes. And then we're going to talk about the common foundation classes that Al mentioned, which are the base classes that we provide objects for strings, data storage, arrays, sets, dictionaries, that kind of thing. And we'll look at some of those, what's available, what you can do with them. So let's start out with sort of the basics of object-oriented programming, just a quick overview. So a class, that's kind of the most basic thing. Can anyone sort of tell me what a class is? It's just a quick, brief description of what you think class is? Yeah.
Blueprint for an object.
Blueprint for an object. All right. Yeah, sounds great. Did I have that up there? I don't know. Okay. Yeah. So class is a blueprint for an object. It's actually a blueprint for instances, right? Which is the next thing up here. When you start out with a class, you're going to create instances of that class, and then individual instances have methods and instance variables associated with them. The instance variables are the data that's associated with that particular instance, and the methods are basically functions that you can call on those particular instances that operate on the data of that instance. So the instance is effectively grouping up the data and the methods that can operate on that data. So there's a few things, just pieces of vocabulary that are kind of important to all this that we'll be talking about over the next few weeks as well. So the first is encapsulation, and that kind of goes along with what I just said about the class containing the instance variables and the data members. The idea here is kind of you want to have the specifics of your implementation hidden behind a public interface. So the public interface is the instance methods, and that's what's exposed to your clients. If you're developing applications, that's kind of a gray area. Your client is generally yourself. You're writing an object and you write the other object and they work together. But when we start talking about things from the Apple side or the framework side, we're exposing most of our interfaces to application developers, to you guys, as objects. And we want to provide a very consistent and supportable interface to those things in the form of the methods that we're providing. But behind the scenes, we don't want to allow access directly to the instance variables or to the specific implementation details. We want to encapsulate all that so that we can keep supporting an interface and still have the flexibility to change the way we've implemented it behind the scenes. So that's kind of the idea with encapsulation. Polymorphism. The idea here is multiple objects can respond to similarly, or well, identically named methods, but have different actions result as a result of calling those methods. So a pretty common example of that, I guess, would be addObject, which is a method both on NSArray and NSSet. So NSArray is a set, or sorry, is an array, obviously, and NSSet is a set. You may have heard this called a bag in other languages or other frameworks. It's effectively an unordered collection, whereas an NSArray is an ordered collection. And you can call addObject on either of those. They both implement the addObject method, but both do something different as a result. Array just appends to the end of an array, and set will just add to the set, while also making sure not to duplicate the object. So the idea is basically you can have a similar interface on multiple objects, and you don't necessarily have to know at runtime which type of object it is you're sending the method to. Things will still just work. And then finally, we've got inheritance, which is a pretty basic concept to object-oriented design. We've got base classes, and then every time you create a new subclass, that inherits from the base class. And you get things like the subclass inherits the instance variables from the base class, but can also add additional instance variables. The subclass can override methods and replace code on the base class. And you can just basically customize and extend the base class that you're subclassing. And we'll talk about it a little bit more later, but the base class for all things in Objective-C that you'll be using is NSObject. It's the foundation class that everything else inherits from, with one or two exceptions, but those aren't really important for the purposes of what things we'll be dealing with. So yeah, inheritance, sort of an example of inheritance in the UI kit, which is the user interface framework for the iPhone. We start out with NSObject. UI control is something that inherits from NSObject. And that actually basically implements some of the basic things that a control object would need to do. Touch tracking, and knows where fingers are when they're moving in and out of the control on screen, and that sort of thing. And then there's specific concrete base classes of UI control. We've got UI button and UI text field are two pretty good examples of that. There's specific types of controls that have a particular appearance and maybe some custom user interaction that is more specific than what the base UI control object provides. But they get all the other behaviors that the basic touch tracking that UI control is providing as the base class. Right. Yeah, NSObject does memory management. It's basically the thing that handles allocation and destruction of objects. In Objective-C, all objects are reference counted. This is kind of different. If anyone's used to dealing with C++, you pretty much use a language construct to create a new object, and then you delete it when you're done. In Objective-C, NSObject actually has a protocol for retaining and releasing objects, which ends up counting, putting reference counting on them. And that's by default for every object. All objects are reference counted. And so NSObject handles that. And then, as I said, UI control providing some of the generic behaviors and specific behaviors on the button and text field. All right, so hopefully everyone kind of already has a foundation with this stuff. But if you've got any questions, things you're not quite sure about, unclear on any object-oriented ideas, definitely drop by office hours to talk about some of the more interesting points about it, I guess. There's tons of books on OOP. There's plenty of stuff available on the internet. And we've got some good documentation at developer.apple.com as well, which kind of provides an OOP perspective from Apple's point of view. And that's available here at the Conceptual Objective-C documentation. So with all that being said, let's talk about the specific language, Objective-C, that we're going to be using to write iPhone apps. So Objective-C, as Al said on Tuesday, is a strict superset of C. Anything that you can write in C will be able to be built and run in Objective-C. You can take any C code and just compile it in your Objective-C app. It'll just work. Objective-C adds a bit of syntax on top of that in order to allow you to have classes and methods and all this kind of stuff. We'll talk about a bunch of that today. We won't get too deep into the specifics of defining an object, but we'll talk about sending messages to objects and working with objects that we've already created, parts of the foundation libraries. And we'll talk more about creating your own objects later on. So yeah, it's Actually, Objective-C only supports single inheritance. It's sort of simplified from the model in C++, where you may have dealt with multiple inheritance before. You could actually have, in C++, you can have multiple base classes for a particular object. They can inherit from 2 different classes. In Objective-C, every class has exactly 1 superclass. So the inheritance model it's quite a bit simplified. It's a pretty straight chain from base class all the way up to its deepest superclass, because there's only ever 1. There is this interesting ability to define protocols. And a protocol is basically, it's a collection of methods that you group together, and you can indicate that a particular class implements this protocol, and that tells the compiler that that class is going to implement that set of methods. Now, some of the methods in that particular protocol can be either required or optional, so the compiler can't always know for sure whether or not you're supposed to be implementing everything, since some are optional. Yeah, basically it lets you define on your class that that thing is going to implement a particular set of methods. And one of the places where you're probably going to see this pretty quickly is the concept of delegates, which we'll see with NSTableView and a bunch of other things. Most delegates in UIKit, a delegate is basically an object that has to ask questions of another object. The other object becomes the first object's delegate, and there's a defined delegate protocol that the delegate must implement, so that the object doing the delegation knows what methods it can call on its delegate. So we'll see that later on. But just keep in mind, protocols are the way that that's implemented, and they're pretty interesting for quite a few things. Objective-C has a dynamic runtime, so it's quite a bit more dynamic than C++. Basically, all method dispatch is done lazily. There's no compile time binding of methods. So when you go to send a message to an object, that the code that's going to run as a result of that message isn't determined until the message is actually sent at runtime. The compiler doesn't get to make the decision about what code is going to run as a result of any message send, which sounds a little bit interesting and maybe odd at first, and seems like maybe it's not highly efficient, but the dispatch is actually super optimized. It's really fast, and it lets you do a lot of really cool things. I mean, you can the polymorphism stuff we talked about before becomes even more powerful when we start talking about doing it with dynamic runtimes, because you don't even have to know what type of object you have when you're starting sending it messages. You can just send a message to an object, and as long as well, I mean, you should be pretty sure that that object actually responds to that message, but as long as it doesn't matter what type of object it was, it'll just respond to it and everything will work, even if it's a different object than what you actually thought might be there at compile time. Objective-C is also loosely typed if you want. Kind of going back to what I just said about having an object that you don't necessarily know its type about, there's a new type that Objective-C introduces called an ID, which it's basically a reference to an object, and the type of that object is undefined. As far as the compiler is concerned, that object implements every single method that any object that it knows about could possibly implement. So if you go to send a message to an object typed ID, the compiler will happily let you do it because it has no idea what specific type of object that is. It doesn't really matter because it's going to get figured out at runtime anyway. You can, however, strongly type things. If you actually define your objects, your variables with a real object type, the compiler will do type checking and verify that the object actually responds to particular responds to methods that you're actually sending it. So you actually get a little bit of both worlds there, and you can work on it either way. And the loose typing actually ends up being really cool and lets you do some pretty interesting things. So we'll probably talk about that more later on. So a few of the syntax additions that we have, there's just a few of them. There's the anonymous object, which I just mentioned. That's the ID. It's the object that can be anything. There's a new type called a class. We'll get into this a little more in just a minute, but basically classes themselves are also objects, and the type that represents that is class. And then there's also a new type that defines selectors, which we'll talk about a little more later too. Well, actually, we'll get into it in a little bit. But basically, it's a new type that defines, a selector. So I'll talk about what a selector is a little bit later. And then there's also additional syntax for defining classes and message expressions, which is effectively a way to send a message to a particular object. So yeah, we'll talk about that too. And then the dynamic runtime. Right. all objects in Objective-C are created out of the heap. You may be used to having seen this in C++, where you can, in your local scope of a particular function, you can just you can declare an object on the stack. Basically, you type the class name without a star, so it's not a pointer, and then the variable name, and that defines a local stack-scoped C++ class. That type of thing doesn't exist in Objective-C. All Objective-C objects are allocated out of the heap, so they're all dynamic. When you go to create an object, it's going to live until you destroy it. It will not be destroyed at the exit of the function that you're in, because they're not scoped on that function's heap. There's some places where that seems maybe a little bit untrue when we start talking about auto-release pools. They can feel a little bit like magic. They're really not. We'll talk about them later. They're actually pretty easy to understand once you know exactly what they're doing. But they're still explicitly managing memory, just with a little bit of implicit behavior that you have to know about. So object-oriented programming with Objective-C. I mentioned briefly already that classes and instances are both objects in Objective-C. So when you declare a new class, you basically get a singleton instance of an object that represents that particular class. It's of type class. And you can send messages to that object. You can basically message a class itself. And that's actually how all allocation is done, by messaging the class, which is the thing that does the allocation of the object itself. Yeah, so you can both message classes and the instance variables or the instances that you get back of those classes. So as was said a little bit earlier, classes are basically a blueprint for particular instances. You'll message the class to get a particular instance made of that class, and then you'll end up with a whole bunch of them that I guess look kind of like poker chips or something. So classes declare state and behavior. The state is what we talked about earlier, the instance variables. They're just variables, they're data that's associated with a particular instance of a class. But what those the instance variables that an instance will have are defined by the class. The behavior is implemented using methods. Those are basically the functions that operate on the instance data. And the instance variables are typically hidden. We talked about this a little bit with the encapsulation. The idea is generally that we want to avoid exposing the instance variables to clients. You usually want to allow access to, if you need to allow access to the data that's in an instance variable, you usually want to declare a method to allow access through that method rather than allowing clients to access the instance variable directly. And actually in Objective-C 2.0, which we have on the iPhone, there's also properties that you can use to do that, which you'll see a little bit later too. They basically declare the methods for you. So everyone pretty much has their own spin on OOP, and their basics are pretty similar, but Apple's got a slightly different view of the world than some of the other languages, and it varies a little bit based on language. Objective-C is very dynamic, so our view of object-oriented programming is a little bit different than what you might be used to from C++ and other languages. So definitely there's some great documentation, again, on the developer.apple.com site, object-oriented programming with Objective-C. It's a great thing to check out for more information about how Objective-C is as an object-oriented language. So let's look a little bit at some of the specifics now of how you actually send messages using Objective-C. So I already mentioned that you can send messages both to classes and to instances. And there's slightly different syntax when these messages are just declared. So when you're looking at a header, you can know, just by looking at it really quickly, whether a message should be sent to the class or to an instance of that class. So at the top, we've got instance methods. They all begin with a minus sign there. And at the bottom, we have class methods. Those are things that can be sent to the class itself. So if you're dealing with a string, we've got the NSString class. And you want to allocate one, you call just NSString alloc. You can send that directly to the class. And then this is actually a pattern you're going to end up seeing a lot, alloc and init. You always message the class alloc, and then the result of that is an instance, and you can message that init. So yeah, we've got a couple examples there. Init, you can call height and walk, which are, height's probably going to return a value from an instance variable. Walk presumably will perform some operation that makes somebody walk. The class would allow you to allocate a new instance with alloc. Often you'll see this pattern as well, convenience methods that return pre-allocated auto-released objects. In this case, that's probably what this is doing, the person method. You probably have a person class here that you call person on, and it returns a new instance of a person just auto-released for you. And then finally, another pattern that we see a lot is the concept of a singleton object. Often you'll message a class with shared something. In this case, we're going to get the shared person object. So you'll message the class for it, and it'll give you back a shared instance. So no matter how many times you call this shared person, you're always going to get back the same instance because there's only ever one of them. It's a singleton. And you'll see that throughout the frameworks. Probably less so in UIKit, but there's a bunch of them in Foundation, and on the Mac more probably in AppKit. So let's look at the actual syntax that you're going to use to send messages. Now you've got an object. You called either alloc init or one of these convenience methods on the class. You've got an instance. So receiver is our instance, and message is the message that we want to send to receiver. So it's pretty simple. It's pretty easy to get a little bit scared at first with all the square brackets that are showing up all over the place and thrown up everywhere, but they're actually pretty easy. They always just bracket a single message. So we've got instance receiver on the left and the message that you're trying to send on the right. So that's a pretty simple case. We're not actually passing any parameters or anything. If we actually had an argument we had to send, it's not too much more at all, really. We just add a colon at the end, and then the argument goes after the colon. If you have multiple arguments that you're going to send to a particular message, then each of those arguments actually ends up being named. And the method name that you're sending is composed, it's the entire thing in yellow there. It's composed of both of the names along with their colons. So if we talked about what is the method that we're calling in that last thing, it's actually message colon and arg colon. And order of these is actually very important because that's the thing that uniquely identifies this particular method that we're calling is the names and order of the arguments. So yeah, the receiver again is on the left. The message name is message and arg, and the two args are passed right after their named arguments in the colon. Does that make sense? Okay. So let's look at a few examples of this. Let's assume we've got a person object already allocated, an instance of that up at the top, and that's voter. So the first thing we're going to do there is we've got voter. We're going to tell it to cast a ballot. That's a pretty simple case. We're just sending a simple message to that object. The second one actually is going to return a value. So it's still exactly the same as if we were just calling something that didn't return a value, except now we can pay attention to the result, and we can just assign it to that integer there. The next one, we're actually passing a value in. We're going to set the age of the voter to 21 there. Now, the third one is looking at the return of the can legally vote method. Presumably, this is going to return a Boolean value, and we're just going to check it in an if statement. We don't have to assign it to anything. We can just use it like you would the result of a function. Next, we've got one that takes two arguments, pretty similar to what we just saw on the last slide there. Going to register for state California with the independent party. And finally, you can actually nest these things as well, which actually ends up being really cool, because if you want to send multiple messages to basically a stream of objects, you can pretty easily just group them all on one line in a method that actually, in a way that really seems pretty natural, and you can just sort of read right across and understand exactly what that line is doing. So in this case, voter spouse is returning presumably a person object, the spouse of the voter person object that we had, an instance of that. And then immediately sending the name method to that, which is going to return an NS string there, which is the name of our spouse. So that's what it looks like to actually call these things. Let's just take a quick look at what it would look like in the header, the actual definitions of some of these. So at the top is the definition of an instance method that returns nothing, and we just called that. That's the cast ballot. So all of these, as you'll see, they're all instance methods because they all have the minus sign on the left. There's no class methods, which would have the plus. So the next one is one that returns an integer. The value or the name inside of the parentheses there is just int, which indicates it returns an integer, and then age is the name of the method. After that, we've got setAge, which takes an integer. So basically, the definitions of these end up just having in parentheses the type followed by the name. Boolean, this is pretty similar to the first one. The one that returned an int just returns a bool instead. Ones that take multiple parameters look pretty much the same. And then at the bottom, we've got two more that are also pretty similar there. So when you're looking at headers, you're going to end up seeing this. When you're actually messaging them, you'll be dealing with this. Oops. All right, so a little bit of terminology about these things, stuff that we just talked about, the different parts of it, what these things end up being. So the entirety of this is considered an expression. It's the message expression. Everything from the opening to the closing square bracket is an expression. Even if you've got multiple arguments in there, all part of the same expression. Then the message that you're sending is, it's basically the method name along with the argument. That's the message that's getting sent to the object. We already decided the thing on the left, the receiver, is an instance of an object. And so the message we're sending is everything to the right. Now, the selector is basically the name of the method. So there's a little potential for confusion here because it's pretty similar. I mean, you might wonder what the difference between a method and a selector is. And that's a valid question. Going to try and explain that, and we'll see how clear it ends up being. I would kind of liken it to functions and function pointers in C. So if you think about that a little bit, a function in C is basically, it's the actual code that's going to execute, right? You define a function, you write some code in there, that's the function, it's the thing that's going to execute. But you can reference that from somewhere else in your code by getting a pointer to it. So you get a pointer to the function, and that's a function pointer. It's not the actual function itself, it's a pointer to it, but it lets you call the function. So this is pretty similar. The method is, it's the code that you wrote, it's the method that you wrote in your class file, and it's the thing that's going to execute. The selector is a way to reference that. Now, because Objective-C is so dynamic, it doesn't actually reference the specific implementation of that method. It references any method that has that same name. But it's basically, that's the best analogy I can get with C. Does that make sense? Anyone unclear on that? Need a little more clarification? All right, excellent. Yeah, the method is the code that's selected by a message. There is one extension to all of that we haven't quite covered, but I mentioned briefly, which is the dot syntax. This is actually the properties that I talked about a little bit earlier. It's sort of directly related to that. So if you want to get to a particular instance variable on a class, on an instance, you'll usually send a message to the class that has the same name as the instance variable or something related. And that would normally look like square brackets, person, and then height to get the height of the person. In Objective-C 2.0, you can also write that as person.height. It is actually identical. It does the exact same thing. It still goes through the normal message dispatch. It's just as dynamic as if you had written the other thing. Literally identical, just different syntax. So if you're kind of a person that likes to write little dots instead of square brackets, go for it. The same thing works for assignment. If you had a set height method and you were trying to pass in a height there, you could instead just write instance.height equals new height. And that will the compiler will turn that into a call to the set height method. Yeah, so as it says at the bottom there, person child set height is the same as person.child.height equals new height. It's just another way of writing out the same thing.
What if we have more than one argument?
I'm sorry?
What if we have more than one argument?
So the question is, what if you have more than one argument? And the answer is, you cannot do that. These are really, they're really designed for property access, which would be getting and setting values. And when you're getting and setting a value, you're generally not passing in multiple arguments. You're just passing the one value. So it's really intended for that. It's just a single argument. Yeah.
Last slide. Were you saying that the equal sign will assign the opposite direction the iteration does, or what?
No, it assigns the normal direction. So person.height equals new height will set the height instance. Well, it'll call set height with the new height value as the argument. So assignment works in the same order that it would if you were just assigning to a value on a variable on the stack or something. All right, so we talked about a couple of new types in Objective-C already. Let's look at them a little bit more closely now. The dynamically typed objects. We've got the ID. That's we talked about it. I don't think we really saw it yet. That's the any object type, basically. You can send any message to that the compiler knows about, and it's not going to complain. It'll crash when you're running it if the object that you're actually trying to send that message to doesn't respond to that particular method or implement that method. It's also important to note that you usually are going to want to deal with these just as ID, not as ID star. Most of the time when you're writing, when you're creating a variable in the stack for a particular class, like if you had a string variable, you'd write nsstring star and then the variable name because it's actually a pointer to an ns string. An ID is implicitly a pointer, so it doesn't actually need the star. If you put the star there, it's actually going to end up being a pointer to a pointer. So yeah, you probably don't want the star unless you really, really mean that. Then there's also statically typed. I don't actually know what that was in reference to. Statically typed object.
Statically typed up.
Yeah, I'm not sure what that was in reference to.
Just the difference between ID, which is
Oh, right. So yeah, then the second line there is an explicitly typed object there. It's explicitly typing it as a person object. So if you send a message to an object, the compiler knows that that thing is supposed to be a person object, and it'll complain if you try and send it a message that the person class doesn't implement. So yeah, Objective-C provides compile time, not runtime type checking. At runtime, it's not going to verify that the message that you're trying to send is going to the object that you thought it was going to at compile time. There's really no verification at runtime. The only verification is if the object that you're sending a message to doesn't implement that method, well, then it's going to crash. All of the type checking is done at compile time. And yeah, Objective-C, as we mentioned earlier, always uses dynamic binding. There's no compile time binding of this message send goes to exactly this method implementation. That's all lazy. The other thing that's been introduced with Objective-C, that's a new type, is the null object. It's nil. It's basically always just 0 typed to as an ID. You can compare it against an object to see if that object is valid, assuming you've initialized the object to nil. You can just implicitly not person. It'll do Boolean logic on it, and it'll just basically validate whether it's 0 or not. You can use it in assignments as an argument. Sometimes the place that you're actually passing it to, many places will accept nil as a valid argument. It kind of depends on the particular message that you're sending, and obviously for your own methods you can decide whether or not nil is a valid argument to your method. Yeah?
Is nil actually 0, or what is its actual value?
So the question is nil actually 0? Yeah, nil is actually 0. It's literally checking to see is the value here 0. Yeah.
So how is that different than null?
The question is, how's that different than null? It's semantic, really. It's all, in that sense, null is also not necessary, right? Null is also just 0. I mean, you can just use a 0. It's for programmer happiness, I guess. Make yourselves feel good about using the right value. So you can also message nil. This is, in most other languages, this would immediately result in a crash and all sorts of bad things. In Objective-C, you can message nil. So if you have an object, or you have a pointer to an object, rather, before you send it a message, you don't necessarily have to check that the thing is non-null. You can just have null and call cast ballot on it, and nothing will happen. It'll be fine. If the method you were sending returned a value, in almost every case, that's totally cool. The value that you're guaranteed to get back there is always 0. So you can actually nest these things, which is one of the places this becomes really cool. If you've got a big nested expression, in other languages you might have to do just the first part of that expression and then immediately follow it with an if not 0 check before you did the rest. Here you can just nest that all on one line. You don't have to bother checking because you know that you can, even if the result of the first message is null, it's totally safe to call the rest because they're just going to be no ops. But yeah, so if you message null, the return value is always 0 unless the return value is a struct type. If the message returns a struct, then the contents of that result when messaging null are undefined. We get lots of good bugs with that one. A common place to see that is when you're dealing with setting frames of views and stuff on screen. You might try and convert a point or something from one, or convert a rect from one view to another, and then set that as the frame of another view. But if you didn't check to see if the thing you were doing if you didn't check to see if the instance you were doing the conversion of the rect with was non-null, and then relied on the result of that message, and that thing actually happened to be null, the rect that you get back is not guaranteed to be 0, 0, 0, 0. It's just whatever happens to be on the stack. So you can get some fun bugs with that. So yeah, if you're getting struct results back from messages, be careful, but otherwise, totally safe to message null. So when Objective-C was introduced, C did not actually have a Boolean type as part of the language. So we have a separate Boolean type defined in Objective-C. It's capital bool. And we've got some separate constants to define 1 and 0 for that. It's obviously capital yes and capital no. We also define capital true and capital false, but yes and no are pretty commonly used. I could go either way with those, really, but and you can also just set 1 and 0 directly. The Boolean type for Objective-C is it's expected to be always 1 or 0. Yes and no, and true and false are always 1 and 0. Of course, if you're doing implicit checking, it doesn't really matter that it's exactly 1. As long as it's non-zero, it's true. Yeah, so those are the macros that are included for that. So selectors, always a fun part here. So there's actually a type which defines a selector. This is the thing that I was mentioning. It's kind of like a function pointer. So selector has the type SEL, and it's often used in UI controls, or probably one of the places you're going to see it pretty often. We've got this concept with controls and a couple other things in UIKit and an AppKit on Mac OS X as well, of target and action. So a control, like a button, might have a target and action. So when the user taps on the button, there's going to be some target object that is going to get some action method called on it when the user taps the button. And you'll see this in Interface Builder too. You can actually set it up visually in Interface Builder. But the action that you're sending is specified as a selector. And the way that you would specify that as a constant in code is you just write @selector and then in parentheses the name of the selector. It's literally the method signature that you were seeing before. So if it took 2 arguments, it would be my method : my argument : yeah, this one actually just takes 1. You can also assign that selector directly to an SEL variable on the stack. Oh, there we go. Conceptually similar to function pointer. Selectors include the name. Yeah. Right. So that's what I just said. Good. So yeah, you can actually do some pretty cool things with the combination of selectors and the dynamic nature of Objective-C. So assuming you've got some untyped object, ID obj, and we've got some selector that we're curious whether this particular object implements, because it's an ID, we don't actually know what the type of the object is. If you just sent that message to the object, yeah, what's
Sorry, I was confused. What is the ampersand sign doing again? No, not the ampersand, the @ sign.
the @ sign? Oh, sorry. So the question is, what's the @ sign doing there? It's the syntax just for defining. I mean, it's part of the @selector. The @ sign in and of itself isn't doing anything. Part of the thing that defines a constant, it's kind of like a constant string, except it's a constant selector. It's basically, it's how you in code define a constant SEL variable, basically.
So you never ever say just selector, right?
You would never actually say just selector. You'd always write @selector. If you're trying to, there's other ways to get selectors as well. If you have a string that represents a particular method you're trying to call, there's another function that you can, another method you can call to get a selector from a particular NS string. But this is how you'd get one if you just knew up front what the selector was that you wanted and just had it in code and just wanted to write it as a constant. It's always @selector and then in parentheses the name of the selector.
But this is still done in runtime like this?
Sorry?
It's only binding to that method during runtime and not during compile?
So the question is, it's only bound during runtime or compile time. That's actually a compile time thing. It's basically setting that variable there to be a selector that references the method start : and that's a compile time thing. Like you can't. So yeah, @selector is a compile time. It's a compiler construct that lets the compiler know that you want a constant selector named start : So yeah, now we've got some object. We don't know what type it is, but we don't want to just call this selector on it because we don't know whether it implements it. And if it didn't implement it, then our app would just crash. So we can actually ask the object if it responds to a particular selector before we try and call that selector on it. So here we've just got a pretty simple if statement. The object call responds to selector cell. And if the result of that is yes, then we know that that thing implements that selector. It's presumably safe to call it. So then we can just tell, we can tell the object to perform that selector. And since it also takes an argument, we're going to tell it to perform selector with object self. And that's equivalent to having called obj start : self in square brackets. It's a way to dispatch it if you have a selector instead of, it allows for a bit more dynamic behavior. If you hadn't, It's less interesting here because we've defined our start selector as a static thing. But if we imagined that that was something that was passed into the function or it was gotten from a string and looked up dynamically, you could actually call arbitrary methods at runtime that you didn't even know what they were going to be at compile time. Yeah, so that actually underlies a lot of the things that we do in Objective-C. We already talked about it briefly, the target and action concept on UI control. And you'll see that more. As soon as you start dealing with the assignment, you're going to see it in Interface Builder, assigning targets and actions to objects. You'll see it visually. But
So self is always receiver of the method?
self is always, sorry, the question is self always the receiver of the method? Yeah, so a method in Objective-C, there's an implicit argument at the beginning of it that you'll never actually see. It's kind of a behind-the-scenes thing. It's just passed around by the runtime, which is always the self pointer. It's the object that the message is being sent to, and self is always that. So if you're writing some code and you're writing an instance method, you can always use self to reference the instance itself that you're working with. It's the this pointer from C++. And if you're implementing a class method, self is also still valid there because classes are actually objects. The self inside of a class method is the class object itself.
One more question. Can you specify the argument name in selector? So add select method name and argument name.
Oh, so the question is, can you specify the argument name in selector? And yeah, that's actually, you have to. The name of the selector is, it's every part of that method name. It's the first name colon, the argument name colon, the argument name colon, as many as it takes. That's the thing that uniquely identifies that particular method is the full name. It's kind of like, well, I'm not sure how many people have seen method or name swizzling in C++, or name mangling rather, not swizzling. Basically, the concept with that is a particular function or method in C++ is named the name of the method and then a bunch of junk added onto the end that represents the types of arguments it takes. In Objective-C, the types of the arguments aren't important, but the names are. So the full name of that method is absolutely necessary to define the selector that represents that method. So yeah, working with classes. So you can ask an object about its class, which is, well, actually you can do a bunch of cool things with this. So you can ask both for the class and the class name. If you ask for the class name, you'll get an NS string back that just is the name of the class for that particular instance. If you ask for the class, you'll get the object back that is the singleton instance of that class. You can actually do some pretty cool things. So if you have an ID and you don't know what type of object it is, you can ask it what type of object it is, or you can ask it if it is a particular type of object. So if we've got my object, we don't know necessarily what it is, but we think it might be a UI control. We can ask it, is kind of class UI control class? So UI control class returns the class object for UI control. Then we can just ask my object if it is one kind of that class. So is kind of class will return yes if the object is either that class or any of its subclasses. If you want to be a little more specific and find out if it's exactly this class but not some subclass of that, then you can actually call the is member of class method, which works exactly the same, just returns only if it's exactly that instance. So for instance, if you pass a UI control in, or if my object were UI control and you called is member of class, it would return yes. But if my object were a UI button and you called is member of class and UI button is a subclass of UI control, this would return no, but is kind of class would return yes. So which one you use just depends on how specific you're trying to be. All right, so one thing that becomes pretty interesting almost right away in Objective-C is how to identify equality between two objects. So the first thing you might want to do is just use normal C equality and just write an equals equals operator there and do direct pointer comparison. But that really is going to do a direct pointer comparison. It's not extended in any way for Objective-C. It won't do anything smart about trying to compare the contents of those objects. Literally just, are these two pointers to the exact same object? Are they the exact same instance? And that may be what you want sometimes, but you may also want to be a little bit less strict about that and test more generically for equality. If you had two string objects that were actually separate instances but contained the same exact string, you could call is equal on them, and it would return yes if they were the same string. There's actually some special cases for NS string that let you do different comparisons based on case sensitivity and some other things, but it also implements is equal, because is equal is defined on NS object. Yeah.
So when we have custom objects, can we actually define custom comparison functions?
So the question is, if you have custom objects, can you define custom comparison functions? And the answer is absolutely. In fact, if you're going to be putting them into arrays or sets, well, arrays not so important, but sets more important, because sets unique objects. You probably do want to define your own comparison function in that case to make sure that the set uniqueness actually is correct. If it doesn't implement them, the set will fall back to doing pointer comparison, and that may not be what you want. There's another similar method that I didn't actually have up here, but it's hash. It's a general method on NS object as well. You can call hash on an object and returns a hash value. Not that interesting probably for your own use, but when you're starting putting objects as keys in dictionaries, NS dictionary actually uses the result of the hash function in order to bucket things in the dictionary. So if you're writing custom objects and trying to use them as keys in dictionaries, it's not going to work correctly unless you also implement both is equal and hash. You may never hit that while doing this, just kind of a aside. Another method that every NS object implements is the description method. The default implementation is not super exciting. Just returns the name of the object, the name of the object's class along with the pointer to the object. You can actually override this as well in your own subclasses and be more verbose, provide some more interesting description information. It's generally used as a debugging tool more than a user-facing tool. You usually wouldn't call description and put the result of that, present it to the user, because generally it's not that interesting. The user probably doesn't care what the pointer to your object is. But it can be incredibly handy for debugging. You call description, you get a printout of the value, the class of the object and its pointer, and you can log it, do all kinds of interesting things. So within format strings, I'm sure you're familiar with format strings from printf in straight C. There's some standard formats you're probably used to with %d for printing an integer. We have an extension to that, not for printf, but for format strings in Objective-C methods, which is %at. And %at is basically a format specifier that specifies this is an object and indicates that when the format string is formatted, it should call description on the object that's going to be printed there and put the result of the description method in place of the %at. So you can actually also just directly log in object description using the nslog function. This is going to log out to the console. If you're running in Xcode, the Xcode actually has a built-in console, so you can just see the output right in Xcode of anything you nslog. It's a pretty convenient way to just dump out some information if you've got some stuff you want to log out, and you'll see that in the assignment as well. And as I mentioned, custom subclasses can override the description method.
We have two at signs in the arguments. What is the first at sign?
Had two at. Oh, right. Sorry. I'm not sure how I skipped over that. So the question is, there's two at signs in that particular line there. So actually, let's go by this piece by piece. NS string is the class, obviously, that we're trying to send the method to. We're going to be sending a class method. String with format is a class method on NS string. And the argument to that is, well, there's actually a bunch of things that are interesting here. So let's just look at the first part, which is everything from the at quotation mark to the end quotation mark. That's a constant constant Objective-C string. So a constant C string is usually just a bunch of text contained between two quotation marks. If you want to define a constant NS object, a constant NS string, so an object, you just prepend an at to that, and the compiler will create a constant NS string for you. You kind of have to be careful about this. If you're sending messages to methods that expect an NS string and you forget the ampersand and just put the quotation marks there, you'll just create a C string, which isn't an object. So when you pass it in, the method you're passing it to is going to try and treat it like an object, and your app's going to crash. So yeah, when you're dealing with Objective-C strings, you definitely want to have the ampersand before it there to indicate that it should be a constant NS string. And then the other thing that's a little weird about this is after the first argument there, we've actually got a comma and another argument, which sort of goes against what I said before, that all arguments are named. There's one exception to that, which is vararg functions, methods rather, that can take a variable number of arguments. Since they can take a variable number, we can't name them all. We don't know ahead of time how many there will be, so they can't all have names. So methods that take a variable number of arguments deal with it the same way that it's dealt with in straight C. You just keep appending them on at the end with comma and new things. So format specifiers, you should have as many extra arguments as you have format specifiers in your format string. I forget who asked that. Does it make sense? Excellent. All right, so that's some of the basic language stuff. I don't know how we're doing on time here. We're doing all right, I guess. So let's talk about the foundation framework. These are the base objects that implement a lot of the data storage and that kind of stuff that you're going to be using throughout all of your iPhone programming. So there's a whole bunch of things that are defined in the foundation framework, actually. We've got value and collection classes. We've got numbers. We've got arrays, sets, dictionaries, all that kind of stuff. User defaults, basically preferences. You can store persistent preferences that get saved out to disk for you. Archiving and unarchiving. Basically, all of the foundation objects, the arrays, the sets, the dictionaries, all these things, they know how to archive themselves, so they can basically flatten themselves down to data to be written out to disk or stored in any way. And then they also know how to unarchive themselves. So after they've been saved out to disk, the next time you run your program, they can unarchive and just expand back out into an entire object graph again. And that's all built into foundation. Notifications, basically ways that objects can send out a notification that they're doing something interesting that other objects might want to know about without those two objects actually having pointers to each other. One can register for a particular notification that it knows another one's going to send. Undo manager, Foundation provides basic undo support. That's actually in iPhone OS 3.0 now. Wasn't in 2.0, but we now have it. Tasks, timers, and threads. Tasks not so much, but timers and threads, you can spawn off separate threads. Foundation provides some basic support for doing that and lets you execute particular methods on background threads or send messages to objects on the main thread. And it also implements timers, so you can get callbacks at particular specified intervals or just once after a particular period of time. It has file system access utilities and pipes, input, output, bundles. Basically, it includes a whole bunch of stuff. There's way more there than we could possibly cover in a short period of time, but let's go over some of the basic things. As I mentioned earlier, everything inherits from NSObject. This is the base class that all these other things are going to inherit from. It implements many basic things like memory management, some of these introspection things that we were just talking about, the isKind class, the response to selector, all that stuff are things that are implemented on NSObject. So every object that you've got is going to respond to these things because NSObject implements them and everything inherits from NSObject. And they also do the basic object equality, although that pretty much just evolves into a pointer comparison. So as we said, if you're doing your own subclass of equality, you probably want to do your own thing. Probably the most common thing that you're going to see in terms of objects throughout your system, and when you start running leaks on your application, which is we'll talk about later, it's a tool to let you examine the memory space and what's going on in your app, what objects are allocated. You're going to see a lot of NS strings, not just your own, but the foundation classes and a lot of the system itself allocates a lot of NS strings. You're going to see a lot of them. It's the general purpose string object that is used throughout foundation, throughout UIKit. You're going to be dealing with this one a lot. It's everywhere. It's a Unicode-based string. It actually, all of the data behind the scenes that it's storing is all in Unicode, so it can deal with all the languages of the world and represent all kinds of great stuff. The fact that this is the basis of all our strings throughout Foundation and UIKit means you can easily deal with all kinds of different languages without having to worry about the specifics of Unicode and how all that stuff works. We just talked briefly about this, string constants. So first example is the C constant string. It's just a simple string there. Second one is an objective C constant string. That's actually an object. Those things actually are NS string instances. So if you create a constant string like that, the compiler will create a constant string for you. The only thing that's a little bit weird about them is they can never be deallocated. They're constant strings, so they're actually in the data section of your executable. So there's no reason that you'd ever deallocate them. They're on disk. I mean, they're there. It's just when at runtime they look like real objects. So if you're trying to sort of debug some memory things and you're looking at your constant strings and trying to figure out why they're not going away, well, they're never going to go away because constant strings don't get deallocated. Format strings, we talked about this a little bit already. Just like printf, but use the %at to print the description of a particular object. If you had there's a string with format convenience method on NSString. It's a class method on NSString. And if you passed it its %at and then a string, it'll just format that right in there and give you back an NS string that contained its Johnny, assuming a string was Johnny. You can also use that for logging. NSLog, we saw a little bit ago, but we only passed it one parameter. If the first parameter you pass to NSLog is a constant string there, you can actually put format arguments in it and then pass a bunch of extra arguments to be formatted in there. So NSLog is effectively a replacement for printf to be used for debugging and that kind of thing. And that's just going to log out something that's been formatted just like it would with printf. So yeah, NSString has a bunch of convenience methods for getting new strings that have been modified in some way. So we've got a bunch of examples here. There's string by appending string, which if you send to a particular NSString instance, it's going to give you a new NSString instance that has the string you're passing in concatenated on the end of the one that you just messaged. String by appending format is pretty similar, except it takes a format string and a variable number of arguments for the format specifiers. And string by deleting path component. If you've got a path to something on disk, basically you can message that and say string by deleting path component, and it'll give you back a new NS string that has the same path, just with the last path component lopped off. So if you're doing path manipulation, there's a bunch of other utility functions in there too. There's one that also appends path components. So it deals with the specifics of worrying about where slashes need to be inserted to specify that a path is broken up. You don't have to worry about doing that yourself. Definitely use the NSString utility methods. They're really great for that. And yeah, that's an example of appending a world to hello, and you end up with a string hello world. So some other common methods on NSString. I mentioned that NSString had a custom is equal method. That's the is equal to string method. There's also another one that takes the options that I talked about, and that'll let you do case-insensitive comparison and things like that. There's also a has prefix method that lets you test to see if a particular NS string has another particular NS string as its prefix. There's an int value, double value, float value, a whole bunch of methods that let you get back numeric values from an NS string. So for example, if we had hello and 449 strings there at the bottom, we could check to see if the my string had prefix he, which it did, so that would return true. And you can also get the int value of that string. Since the value is 449, calling int value on it is going to return as an integer, as an int, not as a class or object or anything, just as an actual C integer, the value 449, so you can compare it directly against another value 500 and find out that it's less than that. And if you call int value or float value or double value or anything on a string that has something that's not an integer in it, you're just going to get back 0. If you call it on something that has an integer followed by a bunch of other junk at the end, it always is just going to give you the value of the first integer it finds. So if you have a string that has two integers, 449 space 449, 500, it'll give you back 449 and just ignore the rest.
So what if the string actually contains 0 and there's one way to disambiguate?
So the question is, what if the string actually contains 0? You can't actually tell the difference between calling int value on a string that contains 0 versus one that contains garbage. In both cases, you just get back 0. Yeah. Yeah.
Wait, so the string has 0, and if you have actually the integer that says 0, there's no difference. Is that what you said?
No, sorry. So the question is, if you have a string that contains 0 and an integer that's 0, can you tell the difference? So that you can definitely tell the difference because assuming the string and the integer are both objects, so they're different types, so you can tell that. No, what I was saying is if you had a string that contained just the ASCII string 0 and a string that contained hello world, calling int value on both of those is going to return 0. But there's no way to know that it returns 0 because the one contained the actual value 0 and the other contained hello world. Basically, it doesn't tell you about failure to tokenize an integer. And then there's also a mutable subclass of NSString, which gives you basically the ability to do a lot of the stuff that we just saw there, but without creating new copies of the string. So you can append things to the mutable string without actually creating a new instance. It just modifies the existing one. All the ones we just saw before, the convenience methods on NSString, returned actually a new instance of a string. So if you start out with an NSMutable string, you can get one by calling just NSMutable string string. And then from there, you can append strings, you can append formats, just the same as you could with the convenience methods to get new ones, but they're just modifying this one object. Yeah, so you can get your string, append high, and then append some more stuff. And yeah. So I also, oh yeah.
Do you have to say how long you want the string to be when you create it?
Question is, do you have to say how long the string is when you create it? And no, you don't actually have to. You can just say NSString string. It'll just start copying it to new memory as necessary if it gets bigger than what can be represented in the allocation that it created initially.
So it might move the memory to somewhere else if it gets too big.
So the question is, will it move the memory? It might move the memory that it's using internally to store it, but this is kind of an example of the encapsulation, right? NSString itself, the instance that you have, is that pointer will remain valid all the time. The memory that it's using to store the actual characters behind the scenes is something that's just hidden by the implementation. You'll never actually get the actual pointer to the memory. So it can reallocate it, move it around all at once, and it doesn't actually affect the user. Yeah. So collections, we talked about a couple of these already. We've got arrays, dictionaries, sets. Arrays are ordered objects, or ordered collections of objects. Dictionaries are key value pairs. So you've got a dictionary, you've got a key and a value. You can you associate a particular value with a particular key, and then you can get that value back by key. Sets are unordered collections of unique objects. So if you, I think I mentioned it may have been called a bag in some other places, but basically you can add an object to a set as many times as you want, and it'll only ever be in that set one time if it's equal to the thing that's already in there. There's a common enumeration mechanism for all of these things. If you want to enumerate through all the objects in your array, your set, or your dictionary, there's just one way to do it, which we'll talk about in just a minute. All of these things have both mutable and immutable versions. The immutable ones are just like immutable NS strings. You can allocate them with a predefined set of data, but you can't change it after the fact. The mutable ones, you can change as much as you want. The mutable collection classes do let you specify how big they are. You can specify 0, which will give you the same behavior as NS string, where they can grow unboundedly. If you specify a value for the size of how big it can be, it's actually going to stop at that size and throw an exception if you try and go beyond it. So if you know that you're only ever going to have 5 values in your array, you might allocate an array specifically with 5 values. But for most use, unless it's really performance-sensitive code, you're just as well off really just passing 0 and allowing it to grow as much as is necessary. Oops, what else was in there? Right. So yeah, some of the basic NSArray methods. The first one there is basically the way that you're usually going to get an array. It gives you an array with a set of objects that you've passed in. This also takes a variable number of arguments, so you'll pass them comma delimited. The interesting thing here is that it doesn't take a count, and so the only way it knows when it's gotten to the end is because the last thing that you want to pass it, the last argument, has to be nil. If you don't pass nil, it's just going to keep reading into memory until it finds nil and trying to add everything it finds in between as an object. Usually doesn't work out too well for you. So definitely when you're calling an array with objects, make sure you terminate it with a nil as the last object that you're passing.
What if it's an int array with zeros?
Sorry?
What if it's an int array and it needs to have zeros?
So the question is, what if it's an int array with zeros? Everything that you pass here has to be an ID, and ID is implicitly an object. You can't pass integers. NS arrays can only contain other objects. If you need to put an integer into your NS array, there's another type, which I think we're going to talk about in just a minute, called NS number, which lets you wrap a C integer as an object, and then you can put that in your array. But you can't put C integers in there directly. And then there's also methods there for getting the count, the number of objects in your array, an object at a particular index in the array, the index of a particular object in the array. If you call index of object and you pass an object that's not in the array, you're going to get back the NS not found constant. That's pretty important to keep in mind, actually. You're not going to get back null. You'll get back NS not found. NS not found is not null. Yeah?
Is there such thing as an NS integer?
So is there such a thing as an NS integer? There is, yeah. It's an object that represents an integer. It can represent integers, floats, doubles. Basically, all of the primitive C types can be represented as an NS integer, which is an object.
What could be the advantage of using NS number? And there's different functions.
Oh, I'm sorry, NS integer. NS integer. I just confused myself there. There is an NS integer, but it's not what I just said it was. NS number is what I just talked about. NS integer is not an object. It's actually a C integer. Don't mind me. Right. Yeah, so when you're looking for, to see if an object's in an array, you'll get back NS not found if it's not there. And be careful of that nil termination, because that will definitely bite you if you don't watch out for that. Mutable array is pretty much the same thing, just add some mutability to the array to let you add and remove objects dynamically. Everything that's on NS array is on NS mutable array. NS mutable array is a subclass of NS array. So anything that you could have sent to NS array, even though it's not defined in the mutable array header, it's valid to send it to an NS mutable array. You can get one again with NS mutable array, or NS mutable array with capacity is the one that lets you specify a particular capacity. This convenience one is equivalent to sending array with capacity 0, so it grows unboundedly. You can add an object, remove all objects, insert an object at a particular index, and yeah. There's a number of other things. They're all in the header and the docs, but you'll see those. Dictionary, there's the common NS dictionary methods. There's dictionary with objects and keys, which is pretty similar to what we just saw in NS array. You pass in an array. The interesting thing here is they're actually, you switch back and forth between objects and keys. So the first thing that you pass has to be an object, and the second thing after that is the key for that object, and then so on and so forth. Object, key, object, key, object, key. So there always has to be an even number of, real parameters there, and then ending with a null again. If you don't end with nil, you have the same problem you had with NS array, so keep that in mind. You can find out the count, how many things are in your dictionary. You can get a particular object back for a particular key. In this case, nil is returned if you ask for an object for a key that's not in there. It's not NS not found, you'll get back nil. So a slight difference between this and, oh, okay, we're running out of time here. So mutable dictionary, same thing, just lets you mutate the dictionary, which the immutable one obviously didn't. Set is just like array, except it's unordered and the objects are unique, so no object is ever in there more than once. Mutable set is the same as that, except you can mutate it. Enumeration is pretty interesting. We'll just, real quick, this last thing is the interesting thing here. You can basically just write it's in compiler syntax now, it's part of the language. For person star person, you can declare your variable right there in array, and it's going to run this code once for every element in that array. Same thing for sets and dictionaries. Basically what you would have done before by actually doing a for loop where you I equals 0, I less than count, I plus plus. This is a little bit safer because if that array gets mutated while you're enumerating it, it's going to throw an exception. I mean, you wouldn't want that to happen in shipping code, but it's nice to know when you're debugging because you really don't want to be changing the array while you're enumerating it. Just got to be careful about that. NS number, we talked about real quick. You can create it with an int, double, get int value, double value, floats. There's a whole bunch of different things. There's also classes for representing arbitrary bytes, NS data and NS mutable data, and dates, calendar date and NS date. While you're working on your code, for the assignments, you probably want to stick with some of the convenience functions for now. The factory methods, NSString has string with format, array has the array, dictionary has dictionary. These things return auto-released objects, so they're going to go into your pool. You don't have to worry about memory management yet. We're going to talk about that in the next lecture, but for now, you can stick with those. You just want to probably avoid the alloc init and the copy methods, which returned objects that are reference counted and that you own. We'll talk about that more next time. More object info is available online, developer.apple.com, and that's about that.
For more, please visit us at stanford.edu.